Now we need to find the equation of filter networks. The study of the behavior of any filter requires the calculation of its propagation constant gamma, attenuation alpha, phase shift beta, and its characteristic impedance. Z0. Okay, so the study of behavior of any filter requires its propagation constant, which is denoted by gamma, attenuation alpha, phase shift beta, and characteristic impedance Z0. So now consider a symmetrical T network. This is the figure. This is port 1, which is given by 1 dash. This is port 2, which is given by 2 dash, and this is Z1 by 2, and this is also Z1 by 2, and this is Z2. Okay, so this is the symmetrical T network shown in the figure. This network is a symmetrical network. It is a symmetrical network. The image impedance at the port 1 dash and port 2 dash will be equal to each other. We say it to be a image impedance, which is called characteristic or the iterative impedance, which is given by Z0. I'll draw this impedance. This is impedance Z0 and this is 2 dash. For the network shown in the figure, if the network is terminated in Z0, okay, the network is terminated in Z0, its input impedance will also be Z0. So the value of the input impedance for the T network when it is terminated in port Z0, we need to calculate the value of the input impedance. So the value of the input impedance for the T network, this is a T network, when it is terminated in Z0 will be given by Zin is equal to Z1 by 2 plus, now this is Z1 by 2, okay, and these two are in series, Z1 by 2 and Z0, these two are in series in parallel to Z2, okay, so I can write this to be Z2, Z1 by 2 plus Z0, this is series and in parallel to Z2, so this is Z1 by 2 plus Z2 plus Z0. Now we know that since the input impedance and output impedance are equal, I can write Zin is equal to Z0. So that means I can write Z0 is equal to Z1 by 2 plus 2Z2, Z1 by 2 plus Z0 whole divided by Z1 plus 2Z2 plus 2z0. I can write z0 is equal to z1 by 2 plus z1 z2 plus 2 z2 z0 whole divided by z1 plus 2 z2 plus 2 z0. I hope you have understood how this has come. Okay, yeah, I can write one more step over here. This part is equal to 2 z2 z1 plus z0 by 2, okay, which is also equal to 2 z1 z2. This 2 and this 2 will get cancelled, z2 will multiply inside, so I'll rub this. So this is z1 by z2 plus this is twice, okay, plus 2 z2 and z0, okay, and that is what we get it over here. Next we'll move forward. z0 is equal to z1 square plus 2 z1 z2 plus 2 z1 z0 plus 2 z1 z2 plus 4 z0 z2 whole divided by 2 z1 plus 2 z2 plus 2 z0. We will cross multiply it, and what we get is 2 z1 z0 plus 4 z2 z0 plus 4 z0 square is equal to z1 square plus 2 z1 z2 plus 2 z1 z0 plus 2 z1 z2 plus 4 z0 z2. Okay, now we can cut this. This is 2 z1 z0, this is 2 z1 z0, this is 4, this and this we can cut it, and what remains is 4 z0 square is equal to z1 square plus 4 z1 and z2, from which I can write this to be z0 square is equal to z1 square by 4 plus z1 into z2, and I can write the characteristic impedance of a symmetrical T network, that is ZOT, which is equal to square root of z1 square by 4 plus z1 into z2. Okay, so this is the characteristic impedance of a symmetrical T section, which is given by ZOT